Okay, so 1.4 is talking about the tangent and velocity problems. So obviously you need to know the difference between a tangent line and a secant line. So those are some of the terms that you're going to hear right away. There we go. Okay, so a tangent line should have the same direction as the curve at the point of contact. So a lot of people try to say that a tangent line just hits at one spot. That's true when you're talking very, very close to that point. But if the curve goes like this, that tangent line at this spot could hit the curve again. Okay, so just be careful of how you define it. But it should not go like through the circle twice. It should just graze the surface. Okay, so when you hear tangent line, it should just kind of graze the surface there. Okay, find an equation of the tangent line at that point. We know shortcuts are crazy. Okay, we can do the shortcuts. What this lesson focuses on is really the concept of it, because a lot of the questions on the AP test are very concept-based rather than just, oh, take the derivative, plug it in, find what the slope is, write your equation. So we want to make sure that we understand, there we go, that we understand this stuff here too, okay? So we're trying to find it at the point 1, 1, which is here. It's not there. No, give me a second to reorient this. What was that? Why? I know, but why? There we go. Okay, we're going to try it again. Okay, that's way better. Okay, so we're trying to find the equation of the tangent line to the parabola at that point. So the tangent line, we could kind of sketch it and take a guess. We don't want to do those things. Okay, what we do with the AB class, and I'm going to fly through this with you guys, is we start with a point up here at 2, 4, and I draw what's called a secant line in that goes through those 2 points. And then I take this point and I slide it closer. Okay, now is that going to be more accurate or less accurate than the first line? More accurate, right? What happens as I continue to slide this closer and closer and closer? It gets more and more and more accurate, right? So what I have in my notes here is if my x value is, let's say, 2. So I start at the first spot. What's the y value that's associated with that? 4. Okay, we're talking about this parabola. And then can't you find the slope between the points 1, 1 and 2, 4? Okay, so you do your change in y over change in x to find what that slope is, and we get a slope of 3 there. Okay, and then you move that, you slide that point closer, so your next point might be at 1.5. You find the y value, your slope there is 2.5. You keep sliding it closer here. Okay, do we feel good about the slope approaching 2 there then? Okay, now think of our shortcut for a second. Okay, if I take the derivative of that is 2x. And what happens when I plug the point 1, 1 into that? We get a slope of 2. Okay, so it should match, you know, your shortcuts and all of that stuff. Okay, so we find that our slope is equal to 2. Now, if your school doesn't do this, they should. You want to use the y minus y1 equals the slope and then x minus x1 to write an equation of a line. Okay, if you're not using this, you're cheating yourself because you're making it a harder problem than it needs to be. So what do I plug in for m? 2, right? You're plugging your slope into that spot. And what do I plug in for the x1 and the y1? Your point, right? So that's what you're plugging into those spots. And then it's super quick. So we're plugging in 1, 1, and we're plugging in 2 for the slope, and then you're done. Okay, it's way easier than using y equals mx plus b. There's way less errors made with this. A lot of times our slope is not 2 when we're in AP Calc BC. Sometimes it's like 1 over e squared. And if you're trying to use your y equals mx plus b, it's really easy to make mistakes with exponents and such. So I would write it like that. Okay, here we have a kind of a similar type problem, only we're not given an equation. We're given a list of data here. So here we couldn't use our shortcut. Okay, what this problem has you do is plot these points out. What it ends up looking like is something like this, where it kind of curves. Okay, we're not going to do this entire problem. And then they tell you to find what the slope is, or approximate the slope at this point. So what they have you do, instead of just, guessing what it is go from this point to this point and find the slope. Is this too steep or not steep enough? This one's too steep, right? And then we go to the other side, and we go from here to here, and we find that, and that one is what? Not steep enough. So what could we do with those two slopes that we calculated? You could average those two slopes, and it would give you a good approximate of it, okay? I think the book also draws in the curve, estimates a tangent line, draws a triangle, and then does a rise over run estimate. But they all kind of do the same thing. It's an estimate. It's not a super AP type question, but that's what I would do, is average those two. So you'd find the slope here, you'd find the slope here, and then you'd average those slopes. Okay, let's slide to the next one. Okay, velocity is obviously huge when we're talking about calculus and physics. It's not always constant when we're driving from wherever you're located to Madison, let's say. You're not always going the same speed, right? You got to slow down when you go through certain towns. You got to slow down when you see cops, stuff like that. So we've got not always constant. When we're talking instantaneous velocity, what does instantaneous velocity mean? Yeah, at that one particular time, right? So if I want to know what my speed was 30 minutes into my drive, I want to know what my speed was at that particular spot, right? So instantaneous. The difference between instantaneous and average is my average velocity would be how fast I went on average from here to there. So there's a time interval, okay? So here we've got, suppose a ball is dropped 450 meters above the ground. Find the velocity of the ball after 5 seconds. So I want what the instantaneous velocity is. I know we know shortcuts, but we don't know shortcuts yet. Okay, we're not doing the shortcuts. So if we're trying to find, because sometimes it does this on that AP test, the average velocity, what I'm going to encourage you to do a lot in this class is think of the labels. So reading through this problem, what do you think the label would be for velocity? Meters per second. Okay, it keeps you from accidentally putting one thing in the wrong spot. So that's what I'm aiming for. So I want my meters on top, I want my seconds on bottom. So if we're trying to find the average velocity, we're doing the change in the meters, so change in position. That's just a delta symbol. And then the change in the seconds, so change in time on bottom. And that will give you what the average velocity is. Now what we're doing right now in AB is we're going to do a time interval, and we want to know what it is at 5 seconds. So we're going to go from 5 to 5.1, and then we're going to shorten that. We're going to go from 5 to 5.01 and keep shortening it to try to find what that is. Okay, it's kind of cute to do it that way anyway. Okay, so we got our time interval. So we would go from 5 to 5.1, and we'd find what the average velocity is there. And then we go from 5 to 5.01. You guys will do this in your homework. Okay, so to find these average velocities, let's just do the first one so you have it for your notes. If you're keeping good notes, it might be super helpful in college to have good notes on this stuff anyway. All right, we want the change in position over change in time. So the denominator should be really easy. Okay, change in time is how much there? 0.1, right? You do the change in time, 5.1 minus 5. And then how do I find the change in position using what I've got in this problem? Yeah, you're using the 4.9t squared, and you're going to plug 5.1 in, find that value, and then plug 5 in, find that value, and subtract those. So I'm going to just write that as s of 5.1, and then minus s of 5. Okay, so we get that should be 49.49, and it's hard to tell what we're actually approaching, if it's going to 50 or what's it going to. If we do this one, we get 49.049, and then this one ends up adding another 0 in there. So what would you say is the instantaneous velocity at 5 seconds? 49. Now, make sure you label your answer. On the AP test, if it says in the wording, indicate units of measure, they give you a point just for having the label. So even if you don't know how to do the problem, if it says indicate units of measure, figure out what the units of measure is and write it down to get that point, okay? So we got 49 meters per second. And I would encourage you to go back to the problem, read it again, make sure you answered the question, because it's really easy to get caught up in the math and go, oh, I got my answer, and not actually answer what they're asking. Here we got it, though. So, any questions on that? Okay, so your homework for tomorrow here, 1 to 7 odd. The answer should be in the back, so you should know, if you're doing it right or not. The big thing with this one is slope. Okay, you're doing a lot of slope, so make sure you know your slope formula, I guess.